All right. Now we're getting to the meat and potatoes of calculus, limits. We deal with these functions. Now, to refresh your memory, the definition of function is anytime you have a one-to-one relationship between an x and a y. For every one x, there is exactly one y. We're not going to deal with the goofy side parabolas in which they go east and west instead of north and south, because they will have two. And they kind of screw things up, so we just deal with half of them instead of the whole thing. But all of our relationships are dealing with functions. Now, this particular function that we're looking at today, I've written like this because when you get into the habit of finding values, it's really easy to screw up something so simple. I mean, I find that the most intelligent people that I've known do the stupidest things in calculating, myself included. I would not eliminate myself from this list of people. Not that I'm saying I'm really smart, but I'm just saying I know as much math and science as I do, that I do some of the dumbest things. And so that's common. But your goal should be to try to eliminate as much as possible, because here's how I operate. And unfortunately, it's who I am now. And I probably was like this before, but I never really had a wife calling me on it as often as I have now. So I get so absorbed in a problem that I would block everything out. And an example, that I have been just busting my neck trying to get ready for this term to start. I mean, I was one of the most thankful people on the face of the earth when they said, oh, you are not going to start for another 3 weeks. I'm like, yes, I got more time to prepare. And so I'm a little more comfortable with this. But man, I tell you what, I was walking around the house like a zombie. My mind was just full. What am I going to do here? Right, I'll do this. Okay, then I have to do this, and then I got to turn around and get this put together. I got to get a letter out to the parents and make sure they understand what I'm trying to tell them and what I'm trying to tell you guys. And then next thing I know, I'm tripping over a piece of wood that is so obviously plain in sight. It is absurd to think that I actually did that. I am embarrassed for myself. My wife started crying. She thought I was going to die from all the blood. I said, no, that's just me. That's just me. So, I mean, but I know I've been this way my whole life. I can remember playing baseball. And I'm playing this Little League game. It was a little important. We're about to win the game. But the only way that we were going to win is if I could steal third. I was on second base. I could steal third. And then the guy who's hitting, who's horrible, he might get an accidental dribble down the first base line, and I can run in and score, and that will be the end of the game. So with 2 outs, I do indeed steal third base. I'm a hero. Yay! My mind is so focused on stealing that base that I did not realize that the ball was overthrown and everybody's shouting at me, and I am just thankful that I accomplished my goal of stealing third. And then the ball gets thrown back in, and then my head clears, and I'm looking at the third base coach, and he goes, what is your problem? And then the guy struck out. Wonderful story, though. That's me. So, what we're going to do here is make sure that you eliminate the stupid mistakes by using parentheses in this scenario. Because a lot of times, and I see this happen all the time, that you do it from one, not the other, or you just won't do it at all, and the calculator does not understand how your mind works. Your calculator has to be told exactly what to do. Use parentheses in functions like this, please. It'll save you a lot of grief. You won't have to hear any more of those stupid stories that I've told you. So, we have this equation, and here is the weakness of the graphing calculator. So, if you were to punch this into your calculator, so we can punch x cubed, and by the way, there is a cube symbol. Hit the x on the xt theta n thing, hit that x, and then hit math, and then 3, get the cube symbol on there, minus 1, close parenthesis, divided by parenthesis x minus 1. Close parenthesis. Then hit zoom standard to make sure it goes to the default mode where most graphs tend to go. And you'll notice this graph. Oh, that's a pretty nice little parabola. Doesn't give the origin. That's kind of odd, but it doesn't. But it's not true. Most of it's true, but there is a point on there where there should not be a point. And we can't see that because this is what we call a macro description and not a micro description. Again, going back to all what calculus is all about the macro, the micro differences, and we're just too used to finding macro differences between points. There is a point on here that we cannot go through in this graph. And here's what it is. X cannot equal to -1. Why? Because when you put 1 right there, that gives you 0 for a denominator, and you cannot divide by 0. Yeah, if you take a look at this, oh yes you can. No, you can't. So we have a limit. We've got to figure out what point that is. Now we use the graph to look at it. Oh, that looks like a 3. But we got to prove it. So we're going to prove that the limit on this is 3. That we cannot, that both sides of the curve will approach it, but it can't necessarily hit it. That there should be a little circle right there showing, you're not going through that point. So it's this is what we call a discontinuous graph. It doesn't go through every point. It goes through all but the point 1, 3. So let's see how we can prove that. All right, so what happens at x equals 1? Since x cannot equal 1, what must f of x not be? That would be our limit to this function. So when we ask for a limit, we're trying to find the point at which something cannot exist, or we're just trying to find the function at that particular point, if that's the end of our graph. So what we're going to do, we're going to find the values of f of x, which again is a fancy schmancy way of saying y. When x is equal to 0.75, 0.9, 0.99, 0.999. So those are increasing towards 1, and then we'll look at 4 points of x, coordinates of x that are going away from 1. And we're going to compare those because the changes in a parabola are very consistent. So I would like for you to pause at this point and just go ahead and type in those numbers in your calculator. Just take a few minutes to get that done, and then when you're done, start the video up again, and I will go 1, 2, 3, pause. Okay, you can start it back up, so I'm assuming you got it all done. These are the numbers you should have done. Now, I should have said it should go to 4 sig figs, and the reason why I do that is because of this number right here. Because it makes it, if you go 3 sig figs, it's 3.00, and it looks like you get 3. When in actuality, it's just a hair shy of 3. And this is just a hair shy of past 3. So these two numbers had to go to an extra significant figure, so I did that to all of them to show what the values are. But as you can see what's going on here, the closer you get to x equals 1, the closer y gets to 3. And you go in the other direction, going from the top of the graph down, that's where these numbers come in, because you're starting at 1.25 and 1.1, 1.01, 1.001. They're getting closer and closer to 3 as well. So the limit of this graph is 3. And we write that like this. And now you can't see this pretty well, but again, you'll get a copy of this and you can follow along on this. So the limit of x cubed minus 1 over x minus 1 as x approaches 1. And this means as x approaches 1, because it can't really get to 1. As x approaching 1 is 3, and you can write it like this, or you write it like this. You can graph this to affirm the answer. You can take a look at that and find one, and what you would have to do, once you've got that all graphed out, the other thing you can do is, and I've been having issues with my calculators on this, and I don't know why, because I used to always be able to do this, so maybe you can tell me that your calculator works and mine's just a piece of garbage, which it most likely is. But what I need for you to do, we've done this already. We did the zoom, and we did the zoom 6, which is the standard or the default mode. Goes from -10 to +10 for x, -10 to +y for 10 for y, and each of these little notches on there represents a value of 1. So you're going 0, maybe 1, maybe 2, maybe 3, and so on like that on the left. Then you're going to hit the trace button. So we hit trace, and right away we get the point, I get the point 0, 1. Okay? Now, what I want to do is get as close to 1 as I possibly can go. So I'm going to hit the right arrow and get that thing so that x, when you see the coordinates on the bottom of the graph, or the bottom of the screen there, I got 0.85 and 2.57, and then 1.06 and 3.1955. So right there is pretty close. Now, what is supposed to happen, and it's not working on mine, and I'm really not happy with my calculator, because it's a lot of money that you wasted on something that's not supposed to do, that's not doing what it's supposed to do. But you hit, at this point, you hit zoom. And I want this to zoom in on this particular point. So I'm going to hit 2. And then I hit enter. Oh, it worked. It actually did it. Oh my goodness. What the heck just happened? Of course, I say it's not going to work and it's going to show me off right here. But anyway, you get a partial graph. That's what it's supposed to look like. Okay? Now, you hit trace. And you see that it's at 1.063 and 3.1955. And then you hit the left arrow, and you get 1.01 and 3.03. And that's pretty doggone close. You do it one more time, you're farther away to like 0.957 and 2.87. So hit the right one again, and that is really stinking close, but we want to get 1.00 for x. So, or as close as you can get, that's really stinking close. I probably should just say, ooh, that's good, I'll stop right there. But I'm going to press my luck. Hit zoom again. Hit zoom in, number 2, 2. And then hit, I don't think it's going to work anymore. I think it's done as far as it's going to go. Hit press, trace. No, it's gone as far as it's going to go. So you can see there that the point is 1 and 3 based upon that. Okay, it's supposed to keep going on and on and on until you get to like, 5 or 6 decimal places. But once you get 1.00 and 3.00, you're pretty much done. We got 1.01 and 3.03, at least I got on this one. I don't know about yours. You might actually get yours to work right. These things, I don't know what's going on. But that's how you use your zoom button to find your limits. So, your assignment then, I want you to do on page 54, problems 2, 4, 6, and 8. Okay? Have fun.